I have a question about neutrophils and IL-23. So I'm not quite sure how deep the sequencing was, if you were, for example, able to catch the transcripts of IL-23 itself. And I'm wondering, because in newly diagnosed treatment-naive pediatric patients with inflammatory bowel disease, at the site of inflammation, we actually found neutrophils as the main source of IL-23. So I was curious if you could look at that.
Yeah, sorry for the detail. I skipped the detail. And yes, so to analyze this, we initially, when we did the single-cell RNA sequencing, we didn't capture immune cells only using the CD45 antibodies. But we are getting so many different cell types, so we cannot actually get any strong molecular signatures regarding the neutrophil. So in the next stage, we only captured the immune cell expressing CD45. And for the control condition, we could obtain like 1,000 cells, 1,000 immune cells, and we could get about 9,000 cells for the severe, the asthma condition. So it's about like, so altogether is like a 1,200, right? 12,000, sorry, 12,000 cells. So that's the depth. And each individual cell, we are getting about 4,000 transcript on average. So that's the depth. I don't know if I can, I answered your question, but we can talk after the talk more.
One more question, Chris?
A quick question. So one of the long discussions in the Immune Cell Atlas yesterday was the paucity of neutrophil data sets being captured even from blood. So this is a request that if you're capturing neutrophils well, could you please include your protocols on the protocol channels?
Oh, I see. I wasn't here yesterday due to the flight accident, but yes, we will consider about that.
Yeah, very important. And
Yeah.
the second question I have is, do you have any way of knowing how mature the neutrophils that you are recovering are? If they're recruited, are they early in the neutrophil lifespan, or are they more mature?
Yeah, we only did a single cell analysis at one particular time point at the later stage. So I assume that's a mixture of the neutrophil infiltrated at the early and both late. We'll look into that probably using the markers, or probably we can do the experiment again at the early point to compare, to find out the answer to your question.
Lovely work. Just looking at your discussion of changes in cell proportions here, this is something that a lot of people in this community want to do, but I think needs to be approached with caution, obviously because of the issues we all know with the ability of different cell types to end up in your resulting data set. So I'm just wondering, and secondly, I guess the issue of perhaps requiring bespoke statistical analyses to be confident about that kind of conclusion. So what's your thinking in terms of the statistical analysis to kind of prove changes in cell proportion? And secondly, what kind of validation you're aiming to do?
So, as you said, it's very true that cell proportions in single cell, especially in single cell technology, can be unreliable at times, especially since we went through fact sorting initially for CD45 positive enrichment. Now, the first thing we did, obviously, before we put this plot down was correct for the initial fact sorting enrichment by looking at the initial number of events detected via fact sorting. But I don't think we've applied any robust statistical tests to then to tell us whether what we see here is actually what is biologically reflected. However, what gave us confidence in this finding, oh, by the way, this is, we're postulating that there's correlation here, but we don't say that there's any causation in what we find here, and that's also reflected in the manuscript. What gave us a lot of confidence is that when we saw the proportions in the number, in the cells that derived from the culture experiments, they matched very closely in correlation to the proportions we saw via single cell. I hope that answers the question.
The question's about RCA, and you mentioned that the reference transcriptome was built of DE genes between different data sets combined. And the question is that DE genes are often confounded by the data set or organ system you do them in, and they describe the differential expression by definition. And so thus creating a reference transcriptome using these DE genes may not be the most accurate. Did you have a curation process for these reference transcripts used by cell type?
Yeah, good question. So there's lots of bad data sets out there. So you have to curate your reference data sets well, and then you impose very, very strict cutoffs on your DE genes, both fold change and p-value. So then you say, okay, I really believe that these are DE genes, right? And they're in the gray area, you don't include them.
Right. Okay, very last one. Very quick. Yeah.
So in the compactness index, you seem to kind of like it when you get small clusters, but sometimes biology just doesn't do that. So how do you deal with the fact that oftentimes you have like all these gradual processes, and so you pick parameters that make things compact, but maybe that's just an artifact of.
So what we've seen is that the compactness index empirically, right, mirrors the silhouette index. And the silhouette index is based on what are the true cell types, what's the ground truth cell types in that data set, right? So you want, if I have two different cell types, I want those two to be far apart, right? If I have, T cells type A and T cell type B, I want the T cells of type A to be close to each other and T cells of type B to be close to each other and far from each other. Otherwise, why am I calling them two different cell types, right? If you want them to be merged, they're not different cell types.
Okay.